Okay. Good morning. So did you hear the sound? Let me see. I think this. Hopefully you can hear it. You can hear the mic, right? Can you hear the mic? Yeah. Okay. Good morning. So if you see the things I brought on the table, one thing is at the end of this lecture, we are going to distribute our midterm exam as well. Okay. The midterm exam overall is pretty good. I think the median is somewhere close to 90, okay, something like 90. Okay. But later I can give you the detailed statistics. But no matter average or median, actually it's pretty high. Of course, we do have a few students got a little low. But if you take care, you work hard for the second midterm or for the final project, I think it still should be okay. But anyway, I will leave about 10 minutes or so. We can distribute the midterm exam. Okay. If you have any discussion, you can come to my office after the lecture. We can discuss a little on the detailed answers. But I think most students got the answer right, so I think we probably don't spend too much time to discuss this. Okay. Last time we discussed about phrase mining. Okay. We introduced the sec phrase, which is a very good one. You probably see if you really go through like a conference proceedings, those titles, you will get a very good, titles and abstracts. You will get very good phrases generated. Okay. And also, if you just use like a query, you put a phrase like data mining or valet parking, those kind of phrases inside, you will get a similar phrases using sec phrase. You get very good phrases. You can see if you get a valet parking, you'll get like a valet, self-parking, valet service, free valet parking, cover parking, those things. It's very much related. How you get this is we take the sec phrase and then we take those embedding methods. Later we are going to discuss a little more on the embedding method. Then you get very similar phrases like this. Okay. Simply says if your phrase generated is in high quality and then you take a phrase as a unit, you try to find similar phrases, you will find very similar phrases based on, like an embedding method plus the phrase mining method. And this method, you probably see if you can find very high quality phrases. This is using English gigawords. You find the phrases, actually many of them are names, very good names, in the sense that people mention this one more frequently. Another thing I should mention is remember the sec phrase using human to do 300 phrases. You say this one's good, this one's not good. You still need a human involvement. Okay. The authors, they just did a little extension. You do not need any human involvement. One called distant training. Distant training means you do not need the 300 labels anymore. But how they find label, because there's a classifier, like a random forest classifier built inside. So you need some positive, negative phrases. What they did actually is, if you go to popular knowledge base, like a Phrase, Wikipedia, DBpedia, those kind of typical knowledge bases, you take their entry as good phrases. Okay, you'll probably see, you say machine learning or artificial intelligence or database systems. Those are the very typical phrases you will be able to find in Wikipedia. Okay, you take those as good phrases. They have many, many good phrases. Then you actually got a very good labels to some extent. then you can run this sec phrase. You will get a very good results. Another thing is you may want to integrate phrases and unigrams, the single words together, say what are the quality one, to get into a uniform framework. That means your output is not just phrases, bigrams, trigrams. You rank the unigrams together with the bigram, trigram, so you get ranked unigrams and the phrases together. Okay, that's also quite meaningful. Another important thing is multiple languages. Okay, remember, we actually just show you the language actually it's not confined to English, because you basically based on the phrases, whether these several words getting together, whether they should be significantly, more informative, more coherent, more complete. So based on this standard, it can work for any languages. Actually, they tried, like we already showed, the Chinese and Arabic, they work quite well, like what we showed this one. They are working on quite a few other languages. They made a very good progress already. I think Jingbo just reported me this week. They already can automatically recognize which language it is, and then they kick in the language package. Some package, for example, okay, just give you a simple example. The Chinese one is very hard just because the whole sentence has no space at all. Okay, so you need some kind of a stemming in a Chinese way. So they actually first do that stemming using some existing Chinese, those stemming way. Then they kick in this phrase mining and find very good phrases. Okay. Yes. Oh, there are some particular papers. I probably should not lecture it here, but you can feel free. We can discuss that. There are some existing packages, reasonably mature one. Okay, it's not easy. Okay, but we can discuss. And overall, I should say this is a very, very interesting method. One thing I probably should say is this one just published within a month got a Yelp dataset challenge in 2015, give this one grand prize. Okay. And then in December, I got an email from TripAdvisor, which is everybody knows if you book flights or book trips online. And they actually need multiple languages. So they play with, because this one is open source, they download it, they actually make it work for their TripAdvisor for English. And they found this one actually integrate with the word embedding methods. They found very, very meaningful phrases and the similar ones they can do clusters. They find very, very meaningful clusters. And you probably can see for the trips, for sure you want to find different topic clusters because it will make a lot of sense. You do marketing, you do problem solving. You have very nice phrases and clusters. It helps the business a lot. And they actually send us email, give us their own blogs, their internal blogs. Actually, everybody can access if you really got the blog address. And they show how they do it, how they really use it in their practice, and different hotels or some places, they actually give very, very meaningful results. Okay. And they want us to work with them to make 10 languages popularly used in the world, and to make the phrase mining really work. Okay. So it's a very, very interesting. The Army Research Lab also install the whole package. They are using it for this phrase mining. Okay. So I give you a bunch of papers. The one we extensively lectured, one is Ahmed Erkishki's paper. That's in VRDB 2015. Another is Jialou Liu's paper and Sigmod 15. Okay, these two papers, one is top mine, one is sec phrase plus, are very, very good papers because it really works. Okay, you can try it, and it's open source. You can really help you to do many things, including you want to do topic modeling. You first do phrase mining, you do topic modeling. You find very, very good topics. Okay. This is another picture for the same fall. You probably can see this is on the top. And the fall, actually, there's such huge water, they drip down flow down in a very, very heavy way, and it's very deep. So it looks really gorgeous. You can see those are the forests, and those are the falls. Now, I'm going to give you another very exciting research paper. It's also developed in 2015 called class type. That means not only we want to do phrase mining, if we want to control the text, really master text, we need to do typing. Okay. And this paper was done by Xiang Ren in 2015. Actually, I just got a notice from Google. Google actually today going to release the 2016 Google PhD fellowship. Okay. And UIC, only one got awarded, which is him, Xiang Ren. And they actually published all the winners for North America, Europe, and the Middle East. 3 regions combined to give award. Actually, it's impressive because for 3 regions combined, North America, Europe, and the Middle East, for data, structured data and the database system, that field, only 1 award given, which is him. Okay, so that simply says the Google evaluation is very, very competitive. But this year, last year he got a few milestone papers. Zach Phrase is his co-author paper, and this one is a leading one. And actually, even in our Yahoo DICE award 2015, all the Yahoo DICE, all the DICE students voted. He also got a golden award. So it simply says he did it really great. And this one is a breaking paper. Actually, I already introduced you one paper, which is a class site. I think I actually did it in the midterm exam, ask you something about class site. And here, that's the paper. It's really like a milestone paper. I probably should say it's a very exciting one. Okay. The general story is this. Everybody, if you want robot, okay, say computer, to read through massive documents, try to understand document, the first important thing is you try to understand what are the types. Okay. For example, I can give you a simple example like this one. This one is a real Yelp. Yelp, some people comment on some restaurants. Okay, the reading one for human, you can read it, it perfectly makes sense. The problem is whether machine can get it. Okay. For example, this example said the best barbecue I've tasted in Phoenix. I have the pulled pork sandwich with coleslaw and a baked bean for lunch. The owner is very nice. Okay. For human, you read it, you say this perfect makes sense. But for machine, how do you know this barbecue, BBQ, is of course, this is a aberration. Actually, if people do not even have any exposure to American culture, even your English is very good, you may not know this BBQ is what, right? And plus, if you check the dictionary, BBQ could be a machine, right, which can cook, can burn the, can make a barbecue food. But this one, the barbecue, obviously, machine cannot be eaten. This should be food. But the problem is, how do you automatically recognize this? Not to say Phoenix. Phoenix is a big city, but Phoenix is also a bird, right? So could you distinguish this one is a city, but it's not a bird, okay? And plus, pulled pork sandwich get together is a food, okay, pulled pork sandwich. But how could you know these 3 is a phrase and they represent the food? All these things, if we can do it automatically, okay, that will help many things. Just thinking about it, you want to do sentiment analysis, you want to do summary of the documents, or you want to do anything like constructing information networks. This is a critical one. Okay. Then we look at how most people are doing. Okay. If you trace this, most people doing this are the natural language understanding people, NLP people, obviously, because those are the natural language sentences. But how the NLP people are doing, you probably, if you took NLP classes, you probably know most people doing this is doing some curation or annotation. That means if you want to understand New York Times, fine. I sample, in a very nice way, I sample, say, 500 documents of New York Times. Like 2013, I sample 500 2013 New York Times. Then you will ask human, in most cases are the natural language processing experts. They know what they need. They may write down this one is noun, this is noun phrase, and then they may say this one is a person, this one is a location, this one organization. Okay, so you probably see you need a lot of human effort. But the problem is not just once you ask human to do it. Okay, you probably ask any NLP people, you say, I labored 2013 New York Times. Now is 2016. Can I still use it? Okay. Most people will say no. You have to relabor it because things happen in 2013, and now is 2016. They are so different, right? There were no presidential debate. There were no Trump, or Trump was a businessman. Okay. So you probably will see there are lots of difference. You want to use the labor data in 2013, you get big trouble. Okay. Then you probably see there are so many human labor involved to label those data, and sometimes you may even disagree with each other, right? So that's the cases. You want to do entity extraction. You need to label 500 documents. Another thing is you say, oh, there are some dictionary like a WordNet or Wikipedia or Freebase. I may use them to link with my documents. Fine. Actually, in the natural language processing, you really want to link with a knowledge base. What do you need to do? 20,000 queries. Those queries, of course, a human will explicitly do it. That's a lot. You think about that's how much work you have to do. You really want to understand New York Times, you need that much work. Okay. This one obviously is not scalable, especially you get into new things. Just give you the new things like tweets, Yelp reviews, Pinterest, all these things. People writing, even the authors are writing in a very loose English. It may not grammar. It may not be right. They may use some very, very, the words usually you may or may not even be able to find in the dictionary because they write it like a half word. They just say this is a word. People can read it, but it's not the machine. Okay. So with this, the linking is very, very hard. They actually, Shannon did this test. Only 7% for the news media, for those social media, only 7%, okay, are linkable. Simply says, you go to Wikipedia, you go to, like a Freebase, you won't find those entries. Only 7% are there. Okay, 93% are not linkable. Simply say, you go to Wiki, go to Freebase, you will not be able to find it. Okay. So that's the problem. We want a machine to do it, or we want to even plainly use a knowledge base to link it. The problem is we want it to be automated. We don't want a human to do this, okay? Especially a human to do this is no good for tweets and Yelp, those not very standard English. So the problem becomes if we really, really have such a need, actually it does. That's why there are so many NLP group are doing entity extraction, and identification just because it's important. Okay. Then the problem becomes, if you give me a set of target types, say food, location, job title, event, organization, these things, and you give me a lot of text like this, like a year preview or something, tweets, can I go through this? That means you want food, you want location, you want job title. I go through this text out automatically mark it. Say barbecue is a food, pulled pork sandwich is food, Phoenix is a location. Can we do that? Okay. So that's a big problem. You can sit back and think whether you can automate the whole process. It's not easy. Right? Now we probably first look at the typical NLP approach. The typical NLP approach, what they do is do feature engineering. So-called feature engineering is they try to find those things. For example, finding n-grams. Okay. Of course, now you can say the n-gram can be replaced by seg phrase, those top mind, those things. That's true. Okay. The n-gram means unigram, bigram, trigram, or more. You find those token sequence in the window. Of course, in the real NLP approach, you still need training even for the n-grams. Another one is part of speech, those tag. Okay, it's called POS tag. That means you go through this, you say this one is a verb phrase, this one is a noun phrase, or you can say this is a preposition phrase or something. You may do gazetteers. That means you may want to get a person name, organization, country, city, idioms, or something. There are lots of dictionary you can use, like a WordNet or something. You can, Wikipedia you can use to gather those names. Okay, and you may do word clusters. That means you want to do word and similar word. You want to embed them together, and you also may pay attention on the cases and the shape. For example, you see whether it's capitalized, like Phoenix is capitalized in the middle of the text. The sentence likely is a city, not a bird, right? So you actually can do this. And we can do chunking. That means try to find using the chunking text. Sometimes you find the delimiter or something. You can get this one, like you get off or in, or you get a verb. You can say that's why it's a noun phrase, the other part is verb phrase. Okay. And you can use some global feature. For example, you use some document level structures or use some positions. You can do this. These are the things people did in NLP. Okay. But the major thing is NLP needs a lot of examples, curations, annotations. You need a human to get involved. Okay. So here you probably see this one is a review paper. I just grabbed this table. You can see if you want to get a name, there you want to look at spelling match, you knowledge-based linking, and name gazetteer. You want to get a document phrase level, you look at a lexical, look at position, look at genre, look at local text. So there are lots of tricks people already developed. Okay. But the problem is if you heavily rely on knowledge base, you heavily rely on curation, annotation, you need a human to do a lot of pre-processing and lots of human work. But it may not be scalable, especially to social media, to scientific literature, like you get a civil engineer and maybe not so many people want to labor it. Okay. So then the problem becomes we want minimal or no human supervision. That means we want a human to be out because you want a scalable, you don't want a human to pay so much to labor it. Okay. But the problem is if you want everything to be found in knowledge base, we know only 7% are linkable. So you want our research goal is probably we have no specific requirement. Every entity must be found in the knowledge base. Then how we can do it? Okay. So people actually develop some kind of supervision called weak supervision or distant supervision. Weak supervision means you manually select some seeds, okay? But you may try to use like a pattern-based bootstrapping or use a label propagation method to get more. For example, if I label Donald Trump, say this is a person, this is a presidential candidate or something, okay, then you may have some way to propagate to, say, Ted Cruz or somebody, say this is also one, okay. But how do you do this? You may base on pattern. Okay, there are lots of patterns you get. You use this pattern, you may be able to find they sit in a similar situation. So probably once you see this voting is how many, you see Donald Trump voting is how many, then you see Ted Cruz, voting is how many, then you may say they are very similar. So to some extent, you can propagate it. Okay, so that's one way to do it. That's a weak supervision. But you still have to label Donald Trump, right? And what about, we do distant supervision. Distant supervision means no human involved to do the label. Where you find labels? Okay, you find labels in some knowledge bases. That means you can go to Wikipedia. Okay, you may find something. Then you may go back, okay, to label something, which is similar to this Wikipedia entry in many ways. Then you may say this is the same type. Okay, and if we want to do this systematically, okay, then we have to think about how we can develop a systematic method to do it. Okay. Now you see this one is from Xiangren's paper. Okay. The picture here shows the whole framework of distant supervision. What is distant supervision? Means you do have a knowledge base, which even in different languages you probably see. Wikipedia actually is published in many languages. You will be able to get many languages, get lots of good phrases, good types as well. Okay, so actually in the experiments, instead of directly using Wikipedia, Xiang actually used a freebase. What is freebase? Freebase essentially is you generate things. Of course, many could be done by human. Okay, in the future, something can be automated, right? So the general philosophy is you take Wikipedia entry, okay, then you look at the type paths, okay. That means, for example, you say this is Washington, D.C., okay. Then they may have a path, say Washington, D.C. is a city, okay, or it's a location or something, right? So you, based on this, you actually can get a type path. Essentially, is you get a type for a particular entry, like Washington, D.C. Okay. Then once you have this, there are many things that are not a label. You cannot find in a wiki or freebase. But then you get into the document, the real document. You get lots of things from your text corpus, like these are typical phrases or sentences you got. The problem is whether you can link them with a freebase. Some you can, but some you cannot. Okay. For those you can link them together, there are still problems. It's not saying you link together is no problem. Just give you a simple example. Washington. You probably can find a Washington in Wiki. But Washington still have ambiguity. You can think about this. Washington could be a government, okay, like in this sentence. Kabul is ally of Washington. Obviously, Washington is a government. It's not a location because Kabul is a city. And actually, it's a city which represents the government. It's Afghanistan government. Okay, so the ally of Washington is not one city is ally of the other. Actually, it's one government is the ally of the other. So in that sense, this Washington, if you know Kabul actually may represent the government of Afghanistan, then likely this Washington is also a government. So in this case, Washington is government. But if you look at this one, okay, you say Golden Bears beat Washington. Okay, then Washington is what? Washington actually is a sport team because Golden Bear is a sport team. If you know it, is a beat Washington. You cannot beat a city, beat a government, right? So it should be a sport team. But the problem is the same Washington different sentences may represent something quite different, right? It could be a state, could be a government, could be a city, could be a person, and now here is a sport team. Okay, so can we, go down to this text automatically, not a human? You can say at this point, this Washington is a sport team. Can we do that? So that looks a very challenging problem, but it's possible if we, if we write a nice algorithm, we may be able to do it. Okay. That's actually the goal of Xiangren, and he did it in a very high accuracy. We'll see how he did it. Okay. The problem he defined is this. Okay. That means he wants to use distant supervision, okay, to do entity recognition in a domain-specific corpus. Domain-specific could be, like if this one is a newspaper, this is a newspaper. This one is tweets, a set of tweets. This is a tweet corpus. Okay, so at this point, he does not want to mix all of these into a very much mixed one because sometimes it causes lots of ambiguity or errors. He basically say, I mine the news corpus, and this one is I mine tweets or I mine Yelp reviews. Okay, but then he wants to build the links. Okay. That means you give me a corpus, not give me one article. Actually, this is very different from many NLP approach. NLP approach in many cases is you give me one article. I try to parse it. I try to use a label. I can propagate it. I try to beat this article to death. Okay, but that's one article. And his approach is you give me the whole corpus. Okay, suppose this one is 2013 New York Times. You give me all the 2013 New York Times. How many? 2013, I forgot the exact number, but it's in the order of minutes. Okay, you know, every day New York Times publish many things, okay, and plus a web or things, it's a lot. So it's in the order of millions of the articles, okay. And you give me those corpus, you give me a knowledge base, which he uses free base, okay. Then you give me a set of target types. That means you may say, I want to find location, I want to find food, I want to find the person, I want to find the, sport team or something. You give me those things, okay. Those are the target. Then he wants to detect all the other mentions in this corpus D, and categorize this one as either this one is a sport team or this one location, this one's like some kind of like a food or something, but also not in the target. He will mark this one is not of interest. Simply says, if you identify this entity, you know this one entity is not a food and not a location, but you did not mention what you want. I just say this one is not in the top, in the interest. Okay, so that's his task. Okay. Then what he did, the general philosophy is, you first detect these entity mentioned from the text. How do you detect it? Actually, he used phrase mining. Okay, that's exactly the group, our group, other students did this phrase mining, become a very powerful tool. He used it. Okay. He actually used, for this particular paper, he used Ahmed Erkishki's top mine. Okay. Because when he wrote this paper, SEC phrase was not fully developed yet. He was one of the co-authors of SEC phrase, but he knows it was not so mature, so he just used top mine. Okay. Then he will map those candidate mentioned to the knowledge-based entities of the target types. For example, if you got say a particular thing, for example, you say United States of America, you find it. So you went to the wiki, you find this one is a country's name. So then you mark this one as a country. Okay. But something you cannot find. A lot of things you cannot find. You have to do it. Okay. That means you already know very confidently, you know the mention and the type. You know United States of America is a country. Okay. Then you can infer other things. Okay. And how to infer it, that's a major game. Okay. But if you want to do this goal actually set, you think it's very nice, very glorious, you want to do it. But there are lots of challenges. Okay. One challenge is domain restriction. That means previously people want to extract this like using non-phrase chunker, using those NLP methods, using different linguistic features. Okay. But they do have domain restriction. That means if you work on very popular like news, you can do it well. Okay. Later you'll probably see. We do show the news. Many NLP people can do it well. But if you get into like scientific article, like you go to medical science, or you do the tweets or Yelp, many social media things, then it can do miserably. You can go down there because simply says what you trained was so irregular, and you try to use parsing, use part of speech tagging, and the English was so irregular or so loose. So your parser build out, you say this doesn't make sense. A human can read it easily, but for machine, anything grammar is wrong, you just cannot understand it anymore, right? So that something, for example, you say in and out. Okay, in Yelp review, it may be very popular. Okay, or but you go down there, they first say all these are stop words. You just fill them out. Then nothing were left. Right? So you have a hard time actually to do a good job. Okay? The second thing I already mentioned is the ambiguity, name ambiguity problem. Okay? You get a Washington, you can see this one, this Washington's plan actually is not a government's plan. It is the sport team plan because Griffiths is a sports. This is Sunday games. For human, you read the context, you know this one means a sport team, not means a government, right? And here, this one is a government. This one is a city. So the Washington has so many different things, right? You drive down there and say there's a Washington Avenue. Actually, it's a street, right? So you can see the typical method in the NLP is you just take the highest vote, okay? For example, if you see in your corpus, Washington in most cases is the state name, okay? Then you just say, the whole thing in this whole corpus, the Washington is a state, okay? Or you can say, I do not know, but I look at distribution. Washington state is high, the government is a little lower, the sport team is even lower. If I got this one, suppose I got from Wiki. Okay. Then what I'm going to do is every time I found this sentence, I give you a distribution. Okay. That's also not good because of the distribution. If it's a sport team like here, you will still say the chance to be sport team is very rare, okay, because it's so low. Okay. So you probably see you don't want to do it in that way. Okay. Another thing is people already found if things are not labeled, not found in the knowledge base, there's some way you can propagate it. You can say, if Donald Trump is labeled, but Ted Cruz is not, you may have some way you transfer this label, say, presidential candidate down to Ted Cruz. Okay. But how? Okay. The problem is people want to transfer using some kind of patterns. Okay. But usually it's very hard to define a pattern, right? Because the journalists can write anyway. Okay. But the most tricky something is even you try to do clustering or you try to define a pattern, when the journalists or when the people start writing, they write in so many different ways may mean the same thing. Okay. That pattern matching becomes very hard. You think about this. This is a simple example. Okay. This one actually taken from the Japan tsunami, earthquake, tsunami, and nuclear accident, that event in 2011 in March. Okay. And you saw lots of journalist reports. Okay. This one says, you look at this 244 means it happens in that corpus 244 times. So that means many journalists write this way, said the resulting tsunami devastated Japan's northeast. They use devastate. After devastate, that's a location. Okay, Japan's northeast is a location. But then there are non-trivial, but 31 cases. They say tsunami that ravaged northeastern Japan last Friday. Okay. They use ravage. But it's the same thing. That's still a location, right? But if you look at it, there are only 12 cases they use this phrase. Said the magnitude 9.0 quake caused widespread devastation in the city. So now you can see there are 3 cases. After this, they all mean a location. Destroy a city or devastate a city or ravage a city. But there are so many different ways to say it. Some, you have a lot, like the 244. That means you give one label, you have 244 cases you can propagate. But the other cases, like this one, only 12 cases. If you do not have a special trick, okay, nobody will want to label everything. You will not be able to say this one after this one is a city, is a location. You will not be able to say it. That means the context has lots of different ways to say it. It's very sparse. You look at a particular way. Okay. We need some way to cluster them, to group them together. Okay. So that's the important thing, is whether you can do these, we call these are the relation phrases. The relation phrase, we can do clustering. Okay. So that's the requirement. This one actually took the 4. It's one small one, actually, among all those big ones. But you can take right, underneath. You can take. Actually the park was constructed many layers. You go to different layers, see different views. This one actually, you just right underneath. You can see the fall. It's gorgeous. Okay. Now we will see what is Xiang's result, his development. He basically used 3 methods. You can see 3 tricks. One is saying he tried to develop is a domain agnostic phrase mining algorithm. That's the one actually he used top mine. Now we can use sec phrase. Actually, many of my group students, they just use sec phrase because the quality you generate the phrase is better. Okay, so that means you use minimal linguistic assumption, but you do want something. Okay, for example, if you just use sec phrase or top mine, he used the top mine. The top mine has one problem is sometimes you generate it's not a phrase, it's a small sentence. For example, we already seen you go to this Mexican one said food was good. Okay, food was good or service is nice or something. It's a phrase. It's a sentence. It's not a phrase. If you add a little, say part of speech tagging, that means you go down there, you say food was good. There's a was, so that cannot be a phrase. It must be a sentence. Okay, so you would say this is a noun phrase. This is verb phrase. You get a sentence. Perfect. You will kick this one out from the phrase. So that means you use part of speech tagging. Instead of you may use semantic parsing, but if you use semantic parsing, you need more training. You need people to do those labels. Suppose the part of speech use a simple dictionary like a was or is a verb. Okay, that's it. Okay, you actually can get into noun phrase, verb phrases. You can easily get into part speech tagging, right? So what he did is he supposed nobody wants to train it. He will not use semantic parsing because semantic parsing needs training. Okay, he just used simple one like part speech tagging. Okay, so use part speech tagging, you can do good phrase mining. Then you get a good set of phrases. It's ready for you to do typing. Okay. Then the second thing is, do not simply merge entity mentions with identical service names. It simply says you get a Washington, you don't say all the Washington's a state name. You don't want to do that. You look at each mention based on the context, based on service name. Then you try to address this name ambiguity. That means you don't say, I look at Washington, I look at the DBpedia or something, Washington is a state, then I label every Washington as a state. That's very wrong. You have to watch out the name ambiguity problem. Then the third one is relation phrase clustering. That's the one we said, devastate, ravage, or, they have lots of different ways to say it. If you finally can say these different ways, I can cluster them together because their right-hand side or left-hand side, they mean a very fixed type. I know if you say ravage something, there must be a location, or devastate something, there must be a location. Then that's it. Okay, I cluster this. I can say the one after this is a location. Okay. So that one, you can address the context sparsity. That means you only say it once or twice, but I found it's in the same cluster. I can use it to propagate my type. Okay. So let's see how he did it. Okay, that's one paper. If you really read it, there are lots of techniques developed. Okay. One is you first do phrase mining, but you use part of speech constrained phrase segmentation. That means not blindly use top mine. You use part of speech tagging to do you get into this phrase in the context, in the text. You say this one is a phrase, okay, but you actually use POS as part of speech. Use this tagging to check whether this one is a real phrase. Like food was good is not a phrase, you drop it. Okay. So that's the case. You find the good phrases. You find the good phrases, essentially you get a candidate, entity mention, and a relation phrases. That means they are an entity, it's just one entity you found, or they are a relation phrase you found. Okay. And those things can be used to mutually enhance each other. Then we'll see how he did it. Okay. What he did is he took those surface mention things, like a Kabul, like a Washington, like those different things, and construct a graph. Okay. This graph you probably can see is a different type. Okay. One type called entity surface name. This square one, this yellow square one, C1, C2, C3 is surface name. Okay. Then this round one is relation phrase name. Okay. Then this ellipse one called entity mention here. Okay. Then what you do is you got the sentence, you get a phrase. Okay. You get those phrases, you go down, you link them. Okay. You probably see this link actually is in different colors. Okay. Well, the different color means, for example, you say, has office at Washington. Washington is at the right part, has office at the left part. You use one color, this purple color. Okay. But if you say Washington announces or Washington declares, obviously Washington is the left side, okay, left of announces or declares. So you use another color to color it. Okay. So you probably see by the color you know the location is in the front or after this relation phrase. Okay. So you probably can see this. Why you do this? You want to cluster them to do the typing. Okay. For example, you say is ally of or has office at or something. You can cluster those different things, especially like here. You probably can clearly see announce or declare. Those are things very similar because it means something in the front. Likely it could be an organization, government, or something. Okay. In that sense, those verbs, you cluster them together. Actually, their left-hand side or their front one, you know the type. You know they are the same type. You can do propagation. Propagation means something you can find in the wiki. The other thing is not. Now you say they are the same type. I can propagate Donald Trump to Ted Cruz. Right? So it's those things. The game can be easily played. So that's the general philosophy. He constructed this one. Not for one sentence, not for one document. You get a lot of things, you put them together. Okay. Why you put them together? Remember, most NLP people were watching for one document. One document, the case happened, very rare. But you get a whole corpus. They will collide, they will help each other. Okay. In one sentence, in one document said about Donald Trump, The other one, the other article said Ted Cruz. There are lots of very similar sentences in those articles. You pair them together, you get a big cluster. You have so many popular cases, your bridge is built up. Okay, that means you need lots of articles to build a bridge. Okay, actually, when this one did a really, really good performance, okay, some NLP people asked me, said, I just cannot understand why you can build this bridge. Okay, then I give them one thing I convince him some way. I said, suppose, okay, this American journalist was grabbed by, say, Taliban, okay, put him in a cell and only give him newspaper in Arabic, okay, or in Darsi, in Afghanistan language, not in English, okay. The first day he read those Darsi articles, it doesn't make any sense to him, okay, he probably will throw it away. But if every day, if this guy was locked there for a year, every day you give these Darsi papers, if this guy is really smart, he finally, after a year, he could figure out, what the newspaper said. Strange or not, I think, there are lots of illegal immigrants. They got into U.S., they do not know English at all, they did not find any teacher. After a while, they figure out they could speak, right? That means you can see that's exactly the way you expose in many, many cases, you build up patterns, right? So then we will see how this whole thing, works. Okay. Then you'll probably see if we construct this graph, then we have many such graphs and many such cases. Something can be linked by wiki. Okay, by Freebase. So then you can do type propagation on heterogeneous graph. That's exactly type propagation says this Donald Trump, this one type is a presidential candidate. If you have so many cases, Ted Cruz is so similar to Donald Trump in many, many articles, you finally this graph will say these are similar patterns. Okay, then they, based on this relation cluster, they are going to be able to propagate from Donald Trump, this example, you can propagate to Ted Cruz, right? So that's type propagation. Okay. And another one is multi-view relation phrase clustering. Okay. How do you do clustering? For example, we just saw that something like Washington declares or Washington announces or something. You have so many different relation phrases like declares, announces, or said something, or, finally you say these things, actually the subject or government or organization, okay? If you know this, that means relation phrase clustering can play the similar role as other type propagation. Okay? Once you cluster them together, you can propagate. Okay? And the bridge, you have many, many articles, the bridge can be built up. Okay. So essentially is you use all these mechanisms like type propagation on heterogeneous graph or multi-view relation phrase clustering, use this to mutually enhance each other. You keep turning this one in the loop. Okay, you propagate. Okay. You propagate, then some good feature can build good bridges, can resolve this ambiguity. Then finally, you will be able to get a very high quality type result, okay, computed or some way. Okay. So that's the whole idea what class type was done. Okay. Yes? Yeah, this is a very good question. The question could be, you can think about this, okay. Donald Trump, now you know this is a presidential candidate. Okay. Ted Cruz actually may play different roles. Ted Cruz is a senator, and Ted Cruz could be a presidential candidate, or Ted Cruz is just a person, okay? Or you do not know, you can say other types. But how do you know, how do you propagate this? What time you can firmly say now Ted Cruz is presidential candidate, okay? This whole thing is built in a framework. I just show you this one a little. You probably will see what is happening, okay? I will go a little further. I just show you this scary, formula, okay? The first thing I should say is everything is soft in the whole process, okay? That means you put this one into the cluster. For example, you say there is a 20% chance Ted Cruz is senator, 20% chance is just a person, a man or a husband or something, and there's another 60% chance could be presidential candidate. Who you want to vote for, okay? The key is you use this formula. It's optimization. You can think it's a joint optimization framework. You have several competing things. Something you do type propagation, some you do relation phrase clustering, some you do the mention modeling, all these things. Everybody can contribute something, and everything is soft. Soft in just a probability distribution, okay? Then you put this one in the framework. It's like iterative, like EM-like framework. You just use those examples, keep enhancing this one or weaken the other one. You do this until it becomes relatively stable. That means now with so many articles, we do back and forth. Finally, when it becomes stable, which one has bigger probability? Okay. Then you would confidently say, now with so many things you propagate back and forth, now I'm pretty sure there are about 80% chance his presidential candidate. Okay. Of course, there still could be some chance he's a senator. Okay. But you say, at least in this occurrence, I'm reasonably sure he's a presidential candidate. You probably can see that's why he got so high accuracy, because he was not eager to claim it before it becomes stable. Okay. And there are so many cases mutually enhance each other. Finally become stable, the chance to be right is very high. Okay. So that's the game. Okay. So it's a very good question. You probably can see the design has to be very subtle, right? So you have to think about all the possible cases. Okay. Now I give you the whole framework of his algorithm. The algorithm, the first one called candidate generation. That one essentially is you first do phrase mining. You do POS tagging. You can first do POS tagging, okay, because it's easier. Even before you get it, you get POS tagging. And you know this is noun phrase, this is verb phrase. Then you can kick in the phrase mining. And of course, they mutually enhance each other. That means your tagging may or may not be quite confident. But after you do phrase mining, like poor pork sandwich, originally you may say this just a bunch of nouns, okay? And then finally you can say these three things, poor pork sandwich, get together, is one phrase. Okay? Then you can say what is the type. Okay? So this is candidate generation. Then the second one is construction of heterogeneous graph. That's a graph you constructed. Okay? And once you construct this graph, you are going to do phrase relation clustering. That means you propagate, you cluster them together, you propagate again, then you can, other things also can be clustered together. Okay? So you do this in a soft way, finally you can get very good clusters. Okay? So we probably can look at each one, how this was done. Okay. So the first thing is about a candidate generation, how he did it. Okay. So what he did is using a phrase mining algorithm. He actually used one which is top mine. Okay. But he did not blindly use top mine. He actually integrate with POS tagging. That means you recognize this is noun, this is the verb. Okay, those things you easily can find. Those verbs are reasonably limited, right? You can find those noun-verbs. You can use POS tagging. And then you can do top mind. You can find good phrases. Okay, then you can you can get good candidates. One thing you probably can see is the verb, because noun is reasonably easy. You can see the verb and the preposition. They can find good phrases in that way. You can see what he got is like a verb. This is about the Japan tsunami one. You probably can see. You get a disperse, you get a hit, you get struck, you get knock. Okay. And you get a preposition like a in, on, off, like at, from, to. Those things is easy. Those are in a dictionary. You can easily assume you know it. Then you may got a verb phrase like a location in, come from, talk to. And you also can get this kind of phrase. It's verb, and there potentially has a preposition, but in the middle it could be a lot of words inside. But you even do not distinguish them. You just say these are a lot of words play one role. You put them together, this is just a verb phrase, like this one. You can see caused major damage on. Okay. You have a cause, you have on. In the middle you have a lot of things like a major damage or minor damage or whatever. Then you probably can say this just a verb phrase you can get. Okay. So remember, if you can get many such phrases in a reasonably complete way, okay, then you will have a power to use them to build up averages. So that one mainly is you want to look at precision versus recall. Here at this point, you want to get high recall. You don't want to miss things. Okay, you get high recall. So you probably can see what he got is he got an entity dimension and a relation phrases. The entity dimension is consecutive nouns. Relation phrases are those things in the table. Okay, you get the different cases. After this, you can use this to start doing all these propagation. But what he wants to first show you is he got a very high recall. He doesn't want to miss anything. Okay, even something could be wrong, like you say this one, it's a noun phrase or verb phrases or something. You can go a little wrong. But the important thing is you first grab them out as a phrase. You can see what he got, what the noun phrase chunking, those typical method got, noun phrase chunker got. The difference, of course, the precision overall is not bad. It's better than noun phrase chunker. But the major claim is a recall. You can see the recall in twits. Noun phrase chunker got 0.118, and he got 0.75. That's a very big difference. Then the twits and the yerp, you will have power later, right? You probably can clearly see this is the advantage. He first say, forget the precision. Why? Because later he has other ways to enhance the precision. Okay. But he first tried to say, don't miss anything. Okay, that's a recall. Okay, so I will stop here. You can I strongly recommend you read the paper, because once you read paper, in the next lecture, I'm still going to discuss this. You are better equipped. You can raise more questions. And this could be a very interesting method. Later you can use it. It's open source. You definitely can use it in your work. Okay. So now I'm going to distribute our midterm exam. Okay. Instead of because we get about 80 people here, it will take a long time to distribute 80 people. Even I would like to know everybody's name. My memory is still probably could fade out after 80 different people. What I can do is this. This one is sorted according to the net ID. Okay, so I put them in 3 piles. Okay, you can pick up based on you guess your net ID is in which pile. Okay, then we probably can you get questions. If you're free, you can ask me. And if you want to discuss with me in detail, you come to my office. Okay, thank you.